Okay, today we're going to be talking about parallel lines. What you're going to be able to do is identify, you're going to be able to graph, and you're going to be able to write equations of parallel lines. It's a lot that you're going to be able to do today. What you need to identify is parallel lines will never intersect. Isn't that true? If I have two lines that are parallel, they are never going to change pace and intersect. Any set of parallel lines will never intersect. Which means if they never intersect, if they're parallel, it means they are rising or decreasing at the same rate. You want to know what rate means? Slope. That means they have the same slope. So write that down. Parallel lines have the same slope because they are rising or decreasing at the same rate constantly. And if they're going at the same rate, that means they have the same exact slope. I have an example here just to identify this. We're going to graph both of these on the coordinate plane that's given. I turned it to plus and negative. My purpose for that is so I didn't forget that it's actually a -1, that this line intersects the y-axis, and then up 1 over 1. Go ahead and put 1 over 1 because some kids think that the slope is 0 because there's nothing in front of the x. That is not true. You have that shy number 1 that's there. You have to make it come out so you know that's the slope. Up 1 over, other way, down 1 over, parallel, or I don't know it's parallel yet. But I bet you it is because they have the same slope, which means they are increasing and decreasing at the same rate. And rate means slope. So I plot my y-intercept at 2, up 1 over 1, up 1 over, up and over, other way, down, over, down, over. Parallel lines. They will never intersect, even though the bottom part of my line is not straight. So if you think about extending it to infinity, the way I drew my line, it looks like it would intersect, but it truly will never intersect. Same slope. What you need to be able to do today is identify slope. So for those of you that have forgotten to get y by itself, adding and subtracting that x term, dividing by the coefficient of y, you have to bring that back today. You need to remember. To work with parallel lines, you need to make sure that it's in slope-intercept form first. That means y alone. You cannot analyze, let me repeat, you cannot analyze slope if y is not by itself. The only way you can analyze slope is if y is by itself. Okay. So parallel lines are the same slope. They have a different y-intercept. My goal for my 8th graders is to always make sure y is by itself, and then I want you to box off the slope. That's your goal, because that's how you can compare the slope, is boxing it off, and then you can identify if they're parallel. So notice y is all by itself on all of these. What I'm going to do is box off all my slopes. Box, 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 and box. And now I can compare. Parallel lines have the same slope. So which ones have the same number in front of x? Let's see. Hey, these two have the 3, so these two are parallel, right? You see that? And then what else? 2/3 and 2/3 have the same slope. They're parallel. Is that it? I think that's it. I have a 4. There's no other 4. A 3 is already connected. -3. There's no other -3. So that's the parallel lines. So 3x minus 2, whoopsie, and 3x plus 2, they are parallel. And then 2/3 x plus 1 and 2/3 x minus 1. Again, what I looked for, same slope. If they have the same slope, it means they increase or decrease at that same rate, which means they're parallel. So one of your learning targets today, I'm gonna give you an equation of two lines, and you're gonna have to tell me if they're parallel or if they're not parallel. And here is how you do that. You have to compare slopes, have to. But you cannot compare slopes until it's in slope-intercept form first, which means y alone. You have to get y all by itself. You cannot compare slopes if you do not have y by itself. So here's how I handle this. When I'm given two equations, I look to see is y by itself on any of them. I see the second one it is, so I box off that slope. And then I need to figure out what this slope is. So I need to get y by itself on this first line. So you have to move your x term, remember, add or subtract the x term. Yep, and that cancels that out, and you get 2y equals negative 3x plus 4. Now divide by the coefficient of y. So I'm going to divide everything by the coefficient of y, and I get y equals negative 3 over 2x plus 2. Now I can box off my slope and compare what you boxed off. Are they the same? No, they are not parallel because their slopes are different. That means these lines will intersect at some point because they don't increase or decrease at the same rate. Look at, I wonder if I want you to get y alone. I wonder. Look at all those lines that are making me yell at you to get y all by itself. So, is y by itself on either of these other two equations? Yes or no? No. So I need to get y alone on both of them. So I'll just do it one at a time. So, add or subtract the x term. So I'm going to plus 2x. Then I get 3y equals 2x plus 4. Now I'm going to divide by the coefficient of y. It's sure going to look ugly, that y-intercept, but I don't care about the y-intercept. I care about slope. I'm not graphing this, I'm just identifying. So I get y equals 2/3 x plus 4 over 3. Box off my slope. The next one, I got to solve for y. So I'm going to subtract the x term, right? Sure am, because I'm given two equations. And I get 3y equals negative 2x minus 1. Don't forget it's minus 1 or plus a negative 1. Now divide by the coefficient of y. Y equals negative 2/3 x minus 1/3. Box off the slope. Same or different?
Yes.
They're different. One is positive, would go like this. One is negative. So they are not the same slope. This is no. Well, no, all that worked. No, comma, not parallel. Oh man. Okay, I'm really messing this up. I'll just go on to the next one. Okay, I want you to notice that y is not by itself on any of them. So I'm going to get y alone. I'm going to plus a negative here because I don't want to forget that's a negative 2 in front of that y term. I'm going to subtract the x term. Go ahead and put your little bar down if you like to do that. I used to not really care, but I've actually grown accustomed to it this year. Negative 2y equals negative 4x minus 2, right? And plus a negative. The reason I decided to plus a negative there is because I see I'm going to divide by a negative 2. And when I divide by a negative 2, I can get a sign error. and you get y equals 2x plus 2, right? Because negative 4 over negative 2 is positive 2. Just kidding, it's 1. Negative 2 over negative 2 is 1. Whoops. And my slope is 2. Okay, next one. Move the x term, and you get y equals negative 3x plus 3. Box off your slope. I have 2 and negative 3. They are not parallel. Bad examples because I don't have an example of a parallel line, but you will have parallel lines today. Okay, they will be the same on some of them. Same slope, parallel, different, not parallel. Get y alone first. There's a reason we've been practicing that. And the reason was all for this lesson, this parallel and perpendicular. Last learning target of the day.